Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. Now, I'd like to start off our event today by thanking Alteryx for sponsoring today's event. Alteryx is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look because they provide a useful insight into a wide variety of topics that are of interest to our data science community. Now, today's webinar is entitled Getting Data Down to a Science, Code-Free and Code-Friendly Machine Learning, and that'll be presented by Ultrix. But before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have 3 presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation because we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Tessa Jones and Hunter Barrett with Decisive Data, and Scott Trouthan with Ultrix. Now, Tessa is the Data Science Practice Lead at Decisive Data. She has over 10 years of experience applying algorithms to a wide variety of problems, including inventory demand planning, marketing initiatives, and space exploration. Now, Tessa is passionate about leveraging data science to have fun and make a difference. Now, Hunter is Decisive Data's Creative Director. He's an artist practicing his skills in a data-driven world. Now, as Creative Director, he coaches clients around visual design and data visualization. He also develops creative strategies like Art plus Data that foster more productive conversation around visual analytics. Hunter's a hands-on maker, and you'll often find him behind a stretched canvas or a print press. Now, Scott is Director of Marketing at Ultrix, and he's been with Ultrix for 3 years, supporting customers and partners in revolutionizing their business through data science and analytics. So Tessa, Hunter, Scott, thanks for being with us today. We're looking forward to your presentation. Now, data science helps answer some of the most basic and the most complex business questions. So in today's Data Science Central webinar, you'll learn how to get data down to a science with code-free and code-friendly self-service analytic platforms. Now, Decisive Data's lead data scientist, Tessa Jones, along with their creative director, Hunter Barrett, will use a sample data set from a global corporation to answer some of the most common data science questions applicable across businesses. So today we'll learn how to use code-free and code-friendly machine learning, swim in the data and dive into a few common business questions and answers in data science, including demand forecasting and customer segmentation, walk through 2 data science models, including code-free time series and clustering machine learning models, customize, implement custom R code into the models, refine, enhance your methods with rapid self-service techniques, and creatively display information visually in Tableau and tell a story that makes the findings clear and captivating using the Art plus Data methodology. So tell your data story and discover the real possibilities with available actionable data science technique. So Scott, with that, I'm going to turn it over to you. You can start as soon as you're ready to go.
Wonderful. Thanks, Bill. Thank you for introducing us this morning, and it's wonderful to be back with the Data Science Central community. My name is Scott Trouthan. I'm with Ultrix, and before I hand it over to Hunter and Tessa, where they're going to show a few practical examples of leveraging data science principles in Ultrix to answer some complex business questions, I wanted to quickly just give you an introduction to Ultrix for those of you who may not be too familiar with us. Ultrix delivers an end-to-end platform that is flexible enough to satisfy the line of business analysts as well as IT and data scientists. Collaboration, agility, and an analytic pipeline that is flexible are all critical in achieving analytics at scale across your organization. And we've noticed that legacy platforms and point solutions fundamentally lack these properties essential to most modern analytic needs. Ultrix delivers a modern end-to-end platform that is purpose-built for today's needs. Our platform is comprised of 4 capability sets that span the end-to-end analytics pipeline. First, we help you discover and collaborate, find and publish the right data and analytic assets faster in a collaborative and governed environment through data discovery and cataloging. We allow you to prepare and blend data, enabling self-service data analytics with drag-and-drop workflows that allow analysts to connect, prep, and blend all your data wherever it's stored. We allow you to analyze and model, develop advanced analytic models in a code-free and code-friendly environment, leveraging Visualytics to see how your data changes across your entire workflow, and finally to deploy and manage. Monitor analytic models in real time to quickly and confidently deliver answers faster than ever before. And across this whole platform, we allow you to scale and govern. We allow you to automate, share, and publish analytic workflows securely across your organization, freeing up time and resources to deliver faster insights to the business. Now, we've noticed, as I stated, a problem with legacy systems, process, and tools. They reinforce silos, not only across analytic teams, but analytic processes, and they contain a myriad of people and tools to produce just basic analytics. Many of these traditional technologies do not provide a self-service experience. The traditional analytic processes are resource-intensive, requiring multiple steps, many specialized technologies, highly skilled, and in some cases expensive workers to draw meaningful analytic conclusions. And this assembly line approach of IT through the different resources to finally to the data scientists, and then beyond that to the line of business, it removes the individual doing the analysis from the actual data, making it nearly impossible for enterprises to realize peak performance in this data-driven world. With Ultrix does not change the process of analytics, but rather unifies this disparate, inefficient process into a single, intuitive, and comprehensive self-service experience for all data workers, from the business analyst to the statisticians, and even expert programmers. At each step of the process, we help users to understand the health of their data and visually understand their models at every step of the analytic process through inline Visualytics. What this means for you, the visual workflows and intuitive drag-and-drop interface of Ultrix, which Hunter and Tessa are going to be showing you in just a minute, eliminates the need to write code and reduces tedious, time-consuming tasks to just a few mouse clicks. It reduces the need for you to code, but if you are an expert coder, whether that be in R or Python or other languages, you can incorporate those codes into the Ultrix workflow. And Tessa will show you how to do this here a little bit later on in the presentation. Most importantly, Ultrix provides the business analysts the time back in their day to focus on what's important, analyzing and interpreting the results for better and more timely decision-making. Now your best and brightest talent can get to drive business-changing outcomes across the organization with less time and effort than traditional patchwork processes. Now, to show a practical example of this, I'm going to now turn the presentation over to Hunter Barrett from our premier partner, Decisive Data. Hunter, take it away.
Great, thanks, Scott. So what I want to do is talk, before we get into the details of Tessa's workflow and the way that she's going to take us through a sample business problem in Ultrix, I just want to give us a little bit of context around why these things are important and how they actually apply to business itself. So I want to just, for example, look at a stakeholder. We'll call him Robert. And he has a big question, which is how and when should we, his company, market to customers? Now, this is a relatively common business question that we see in our consulting work very often, and it's one that data science can help us answer. Fundamentally, Robert struggles to understand the profiles and the behaviors of customers. Companies often struggle, therefore, to effectively market to their customer base without an understanding for their basic characteristics and an understanding of how they might behave. So Tessa is going to take us through a series here of kind of workflow data science steps using Ultrix in the R language to help us understand profiles and also the behaviors of these customer groups that Robert has. And then finally, after that demo, we'll go ahead and look at a potential visualization using Tableau that Robert might use to drive more insight into his business and really developing an analytics tool that's going to help him make better decisions about how to market to customers. So with that, I think we're going to move to a demo, and I'll let Tessa take it away.
Great. Thank you, Hunter, and thanks for having me today. It's a pleasure to be here to walk through the wonderful use cases in Ultrix with you today. So on the screen, this is the basic Ultrix platform. This is the designer. This is where you build your workflows to munge your data, work through your data, apply your data science models, things of that nature. I only have about 30 minutes today to walk through things, so I'm not going to dive too deeply into the details. However, if you would like to receive the final workflow in addition to the sample data sets, just contact us and I'm happy to send it out to you so that you can walk through it yourself. So within the designer here, we have, this is where we're going to build the workflow, and then up here you have all these different tabs that are basically macros that you drag into the workflow to do certain functions and operations. So the first thing that we're going to do is pull in our data. And as Hunter said, our main objective here is to define customer profiles and to understand their behavior. So the first thing that we're going to do is understand customer profiles. So we're going to cluster them into different groups based on the information that we have. In the sample set that we've created here for this demonstration, we have customer IDs, we have average amount spent, age reference, family size, education in terms of the numerical value, income, whether or not they're do-it-yourselfers, whether or not they're homeowners, and if they have a child. So we're going to first go through and Ultrix has a series of data investigation macros that help to first understand the data, what we're looking at, which, as I'm sure most of you know, is a really good first step for data science. I'm just going to look at a couple for the sake of this exercise. The first one we're going to look at is association analysis, which brings us to understand more about what variables in our data are correlated to one another. The other one I'm just going to throw on here for fun is a histogram. We're going to go ahead and look at a histogram of income. And then we're going to add some browsers to this. The browsers are attached to these nodes at the ends of the macros that allow us to view the output. We have different kinds of output in the macros. R is a report, and I stands for interactive. So we're going to go ahead and press go, and it's going to push through these macros and then give us the results. So the first one that pops up here is the histogram of the income, so we get a general idea of the customer profile as a whole in terms of their income. Then we can go to the association. So back here, I had defined that I wanted the Pearson product momentum correlation. There's a couple of other options here depending on what you like. And so therefore, it shows me the correlation, the Pearson correlation analysis for each one of these variables in the data. There's also a visualization tool here that basically gives you the correlation matrix to see it more clearly if you're a more visual person. So we can see here that income and education are correlated, which you would expect. Child and family size is correlated, which you would also expect. Age reference and child are negatively correlated, which again you would probably expect. So we're going to fast forward a little bit and presume that we've done a lot of data investigation, and we've decided we're going to move forward with customer segmentation exercise. But first, we're going to go ahead and try and reduce the number of variables that we're pulling into the clustering algorithm. So we're going to perform principal component analysis to reduce the number of variables that we have to input into the clustering exercise. So the first thing that this macro is going to do is help us define the appropriate number of principal components. So we're going to go ahead and select all of these features that we want to be incorporated into the principal components. We're going to go ahead and scale each field to have unit variance. And I will go ahead and throw some browsers on here so that we can look at the results. And we'll press go. And then it's going to output it's basically created all these different principal components, and it gives you information about the component loading, the impact of each of these variables to the different principal components, gives you some general statistics around each of the components, and then it gives you a scree plot, all which is really helpful in determining what the appropriate number of principal components is to optimize the amount of information that you have within your components. So based on all this, it kind of looks like 4 might be the right number of principal components for this particular data set. So we're going to go back into this macro, and we're going to say that we want to append the principal components to the data stream so that we can see the principal components attached to the customer ID. We know that we want 4, as we've just discussed. And then, so now we know how many principal components we want. We're going to go ahead and remove these browsers. And the O here, I don't think I really discussed that. That's actually, that stands for output. So we're going to go ahead and put a select tool on here. And then we're going to run this again. And it's going to append the data. So here we have the customer IDs, all the information we discussed earlier, and then appended to that, we have the 4 principal components that we're going to use for our clustering exercise. But we don't actually care about having these, obviously, in the clustering exercise because we have condensed all this information down into these principal components. So we're going to go ahead and select the ones of interest, and then we're going to go back to our predictive grouping macros. And we're going to first, I've already determined that we're going to use k-means for this exercise. And so we're going to use the k-centroid diagnostic macro, which is a tool that helps us as appropriate for our given data set. So we're going to use k-means. We're going to use a minimum number of clusters of 2, and we'll boost this up to 6. And then again, we'll add a browser to the end of this, and we'll go ahead and push go. So what this is doing is dividing the data into, it's basically generating different cluster groups. So a series with 2 clusters, a series with 3 clusters, and so on and so forth. And then it's generating the statistics that are useful for determining how many clusters was optimal for this particular data set. This particular macro leverages the RAND indices and the CH indices, which looks at the variance between the clusters and the variance within the clusters. So once this completes running, we'll be able to look at how many number of clusters is most optimal. So here we have a breakdown of the RAND indices for each. So this is with 2 clusters, 3 clusters, 4 clusters, and so forth. And it gives us the statistics around that to make a decision of what's optimal. And then it also plots that in a graphical sense. So based on this, we're looking for maximum values. And so we're going to go ahead and presume that we want 4 clusters for this particular exercise. So because this macro is purely diagnostic and is only really intended to understand how many clusters we want, we're going to remove them. And then we're going to go ahead and put this macro on here and say, we're going to name it. This is the customer clusters. And we only want to use these inputs to generate these clusters. We're going to use k-means, and we've just established that we want 4 clusters. And then in addition to that, we know that we want to append the clusters or the results to the data. So we're going to go ahead and run this. All right. Great. And so now we're going to go here, excuse me, and we're going to append it to the data here. So now we see we have this, and we're going to run this again. So now in the output, we have for each customer ID, we have their principal component values along with the cluster that that particular customer belongs to. But we're not particularly interested in these principal component values because they're not particularly useful in terms of describing a customer. So we're going to go ahead and join this to the original data because it has the data that we're actually interested around the particular customer. And we're going to join it by customer ID. And then we're going to remove the principal components because, again, we don't really, those values aren't very meaningful. And if we run this again, the output will basically be a table that has the customer ID, all the customer attributes that we're interested in, and then the customer group that they belong to. So now that we have successfully segmented our customers into clusters, we can use this data to apply some general statistics and visualizations to describe and profile our different customer groups. So now we want to understand more about our customer behavior. And we're going to look at customer behavior in terms of buying trends. And so we are going to go ahead and pull in revenue data. And we have basically merged the revenue data with the cluster that each customer has belonged to. And as you can see here, we have information for each customer by month and how much they spent and what cluster they belong to. But we're not going to do demand forecasting by customer. We're going to do it by cluster because we want to understand these in terms of groups. We want to understand behavior in terms of groups. So we're going to go ahead and group by the date and the cluster that they belong to, and we're going to sum the revenue. And then this select tool allows us to do a few things. We can select the things that we're interested in. We can explicitly say what we want the data type to be, and we can rename them. So we're going to go ahead and throw one of those in there. And then we're going to do a sort because we want the data to be in order by date when it goes into these macros. So we're going to do some time series analysis, but for the sake of time, I'm going to go ahead and just use one use case. So we're going to look at one cluster group. It is fairly easy in Ultrix to generate a macro or for loop where it can iterate through all of these clusters, but due to time, we're just going to stick with one. So the next step is to divide our data into test data and train data. So in order to train the model, we're going to look at all data that is prior to November 2017. And then we're going to go into this time series set of macros. And Alteryx offers two out-of-the-box solutions, ARIMA and ETS. We're going to go ahead and look at both of these. We'll start with ARIMA. So first you name the model, and then we set our target field. We know that we want to predict revenue. We've also talked about how it's by month. And then in the model customization section, there's a lot of different things that you can do here. They have the non-seasonal components and the seasonal components. You can customize differencing or auto-regression components. We're going to go ahead and add 1 degree of differencing. And then you can also customize how you want to do your information criteria. You can do a box-Cox transformation. We're going to go ahead and apply that as well at a 0.8. And then you have other options here where you can say, well, we're going to go 6 months out. That's how many series we want to predict out. So you define that here. You can also explicitly define a starting period. This by default starts by after the maximum date that's put through the model. We're going to go ahead and throw an ETS model on there as well. The same thing here, we're going to go ahead and name it ETS, and we're going to predict revenue, and again, it's by month. And then in here, you have some control over the error type, the trend type. You can either select auto, additive, or multiplicative, or just none. You can apply dampening, or you can just have it automatically determine if it's needed. And you can determine the seasonality type. We're going to go ahead and select additive for this exercise. And then in the other options, you can do information criteria. Again, you can select what you want. You can apply a box-Cox transformation. Again, we're going to do 0.8. You can then select the number of periods that you want to go out again. So we're going to go ahead and run this and add a couple of browse tools at the end so we can look at the results together. So we'll go ahead and let this run. And it's training the model on these, and the results give us some understanding around how the model performed. So it gives us some statistics around the error and the coefficients, the information criteria. For the ARIMA models, it gives you the autocorrelation functions so that you can better understand how your model's operating. And if you want to further customize it, it gives you some information around how to do that. The ETS, so this is the interactive output, and so it's formatted a little bit differently. So you have your observed data. This is your general trend with seasonality removed, and then it gives you your seasonality, and then it gives you what your predicted values are next to your observed values. Then down here, it gives you some different options of how to look at error. And, and how to look at your information criteria. So you can click through the different options that you want to look at. So now we have two models built, and Alteryx actually offers a tool that allows us to explicitly compare them. So we've only looked at them relative to our trained data. So we're going to go ahead and union these models together, and then we're going to use a macro that's called TS compare that allows us to look at the models that were trained and then apply it to, we're going to go ahead and back out the test data. So we're going to take the test data from over here where we were differentiating between test and train. So we take the false section, which is anything greater than or after November 2017, and we're going to just see how it performed. And then we're going to go ahead and add a browse to the end of this and hit go. So it's going to take these two trained models and apply it to our test data and then provide us with some statistics to help us understand how they compared to each other and which one might be operating best. So we go in here and it gives us tables around what the actual values were, what ARIMA resulted in, what ETS resulted in, the accuracy measures, and then down here it shows you the overlap between what was predicted and what actually happened. So these are very useful tools in terms of not only implementing time series, but also sort of understanding how to develop a time series model. So this is great. However, if you want to implement a more custom model or a model that's not even offered in Ultrix, or you just like writing custom code, that's also a completely viable option. So I'm just going to quickly show you how to do that. So in here you have the same input model. I grouped them and then I selected them, and in the developer tab over here there is a macro that is an R icon, and basically you just input your custom R code into this macro. In here, this is just something I wrote in RStudio and then imported into Ultrix. Here I'm calling all of my libraries, and then Ultrix leverages a particular library that's specific to Ultrix, and so it has specific functions for reading in information. And actually they have a handy dandy thing up here so that the syntax is easily readable. You just say what you want to be able to do, and the code shows up here for you to be able to leverage and see. So in here, I just assign the incoming data that I've input into here into a data frame. Ultrix by default imports strings as factors, so I've incorporated this because I don't want my strings to be factors. And then basically this is a very simple R script that does basically the same thing that we looked at in the ARIMA macro earlier, but it loops through each of the clusters, it separates it into general trends and seasonality, and applies an ARIMA model, and then predicts out into the future. And I have it going 6 months out. And in this particular example, the output shows, so the month here is basically months out from the maximum month that was input, and what cluster it belongs to, and then what the prediction is for that particular month. So really quickly, I'm just going to kind of make that a little bit more meaningful within Ultrix itself, because the way this is formatted isn't particularly useful. And for me, honestly, my favorite thing about Ultrix is that I can very easily and quickly kind of assess data, munge data, clean data, and organize the data, and focus most of my time on hyperparameterization and customization of my models to ensure that they're operating as well as possible. So I happen to know that the max date for all of the different clusters is the same. So I'm just going to go ahead and select a max date from here. And then I'm going to append that maximum date to my output so that I can add, as I said, these months are basically additive to the maximum month that was input. So then I'm going to add a formula tool here where basically I'm going to calculate the date from the max month. So we're going to say date, and then we're going to apply this function that basically takes that max date and adds the month value here, and the date time function is by month. So we're going to go ahead and run that, and then you'll see that this is going to iterate through each of the clusters, and it gives you the output of what it's doing down here so that you can see what's happening. And it's going to generate our predictions for each of these given clusters. And then it's going to go through, and now we have our predictions, and we have our month and cluster like I showed you earlier. All of these have the same max month, but now we have something that's a little bit more meaningful where this prediction is associated to this point in time. And this is a little bit messy still, so you can easily just slap on a select tool. This month parameter isn't particularly meaningful, and neither is max date. And we don't want date to be date time, so we're going to go ahead and format it to be date. We can rename this to be forecast, and then you can run it again, and then your output is a little bit more meaningful. So now what we've done, we've segmented our customers by reducing the amount of information that we have going into the clustering algorithm. We've segmented our customers, and now we have information about not only the historical trends of our different clusters, but then future trends of our given customer groups. And we can use that information to understand more about what our customer profiles are and how they behave, so we can make decisions around marketing. And so now I think that Hunter is going to walk you through the visualizations that kind of came out from this to kind of circle back the whole story of how we can leverage the results of this exercise.
Great. So thanks, Tessa, for all of that. Like Tessa said, I'm going to kind of take us through a visualization, which you see in front of you now, that looks at a lot of the analysis that we've heard Tessa talk about for the last 20 minutes or so, right? So immediately, we see that in this visualization, in this Tableau dashboard, we're actually doing an analysis by cluster. Now, this would have been really difficult and would have taken an incredible amount of time if Tessa hadn't have leveraged Alteryx in the way that she did. But because she did, the output of that data allows us to very easily analyze these groups side by side. The next thing that we notice is that by cluster, we're looking at the same metrics across the board. So we're looking at, for a given cluster, how many of these customers have children, how many are tagged as homeowners, how many are do-it-yourself shoppers. We can also see as we move down, there are a number of bar charts that allow us to see the distribution for metrics like family size, income, and how much money these people spend. So we can see that cluster 1, for example, has relatively small family sizes and a high income. Cluster 2, by contrast, has medium or larger families, and again, are in that more middle income range. What we can do too, on the top right of this dashboard, we can see there's a trend filter. I can go ahead and pull this filter back to the left to include more dates. And what we'll see is our trend lines at the very bottom of this dashboard will change dynamically so that we can actually see more data than we're seeing now. If we look at the trends in their current state, we can see a black line that shows that revenue data that Tessa brought in. And then it actually changes to a green line where we see a prediction of, if these customers were to continue to behave the way that they have in the past, what does our predicted revenue look like for these groups or for these customers from cluster to cluster? We can see that clusters 1 and 2, the trend that they have look more like maybe a seasonal group where they may spend more money at different times of the year, whereas clusters 3 and 4 look like they have a generally just have like a steady incline over time. So these things are going to be really useful for Robert, our stakeholder, as he looks at his data and begins to analyze it in this way, so that he can really understand, again, what the profiles of these customers look like, what are their characteristics, and then what their behavior has looked like in the past and how it may look moving forward. So what we'll do now is I'd like to just talk a little bit about the relationship that Decisive Data has with Ultrix specifically. This last year, we were the Rocket Partner of the Year, which means that we're growing really fast and using Ultrix in a lot of really great ways. We have an Ultrix practice here at Decisive Data. These are people that use Ultrix and are experts in using the product, and we're really excited about the application that it has to organizations that are trying to better their analytics culture, kind of on the road to robust data visualization. So I speak for myself, for Tessa, and for Decisive Data at large when I say that we'd be really excited to talk to anyone about the ways that this product is best applied. And with that, I'm going to send it back to Bill for Q&A.
Well, Tessa, Hunter, Scott, hey, thank you so much for that excellent presentation. And we'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a lot of questions that have come in, and we'll do our best to get through that in the time remaining. So let me move us to this slide, which I'll leave up during our Q&A. In case you'd like to contact Tessa, Hunter, or Scott following today's webinar. So let's go ahead and get started. Hunter, would you please end your screen share? Thanks. Okay, so let's get started. Tessa, those macros that are so powerful on the top of the Alteryx platform, can you, if I wanted to see what was going on inside those, can I look at the R code in there and see how it's being interpreted?
Yeah, you can. Let me show you that really quickly in in Ultrix, excuse me. So I'm going to go back to my Ultrix workflow here, and this is the one where I have these time series macros. And basically what you can do is you can right-click on here, and you go down to open the macro, and it basically shows you everything under the covers of what this macro is actually doing. And if you wanted to see the R code, you'll see this R macro in here, and you click it, and then you can go over here, and you can see all of the R code that went into this particular macro. You'll notice that a lot of the code in here is actually around whatever selections you made in the macro. And then you can get to the point where you see the meat of when the ARIMA model is called. And if you wanted to, you can leverage this and alter this and leverage the functionality however you want. And if you don't want to just straight up write your own custom model, you can also come in here and modify it if you would like.
Well, thank you. And while we're here in the Alteryx view, can you tell us a little bit more about the other machine learning macros that are offered by Alteryx up there on that top line?
Yeah, sure. So there's a couple that we didn't really get into at all. So there's this whole predictive group here. You can do boosted models, decision trees, random forest, gamma regression. There's some stuff to kind of supplement how well these models are doing, like lift charts and a scoring. You have neural networks, neural analysis, naive Bayes, some regression stuff. There's several options in here in terms of predictive. There's some A/B testing macros. So if you're doing some A/B testing exercises, there's a few things in here that can help support that. We have a couple of prescriptive macros around optimization and simulating sampling and scoring. Let's see, they also have an interesting spatial section here where you can calculate drive times, you can calculate bird's eye distances, things of that nature to do some more spatial type of analysis. And I don't think I went into this developer tab, which is where you actually get your custom R here. Those are some of the main ones that are right out of the box within Ultrix.
Okay, well, thank you. Thanks. And let's come back to the QA screen. So, Tessa, Hunter, I guess this is for both of you. What we've got here is a very powerful tool that sent some interpreted data to a Tableau display. I presume that you can share this with any of the business users you want, and that there's some ability to update that as new data comes in. Can you describe how you go about sharing that with other users and how you make sure that that's continuously updated in some sort of workflow, I suppose?
Yeah, I can answer at least part of that, and I'll let Hunter answer to the Tableau side of it for this particular example. But within Ultrix, you can actually schedule workflows to have the workflows run as frequently as you want. And as part of that workflow, you can output the data set to a TDE or an Excel file, or there's a plethora of different ways you can output the data that particular dashboard would point to. And then I think on the Tableau and Power BI side and whatever visual analytics tool you're using, there's several ways that it's connected live to that data set so that whenever you run the workflow and republish that data, it will automatically refresh the dashboards.
Okay.
That's absolutely correct. So when a data visualization receives, specifically a Tableau visualization receives new data, it will automatically display the refreshed data. There's no real need to kind of republish the visualization itself. We refer to those as kind of like refresh schedules. The vast majority of organizations I've worked with will have a refresh schedule of at least once a day, so that every morning when employees come to work, they can log into a data visualization platform like Tableau Server, for example, and the data will be changed dynamically by day.
Okay, well, thanks. That makes perfect sense. Now, you talked about Tableau Server, so I need to ask, is there a desktop version and a server version? Is this all on-prem? And how scalable is all of that? What happens when we get to millions and millions of rows?
Sure.
I think that. Oh,
go ahead,
Hunter. You can. Oh, I can answer part of that, and then I think Hunter can answer the visualization part of that. Ultrix has several ways to help make it scalable. One of the really cool things about Ultrix is that it has an in-database suite of macros that allows any kind of, if you wanted to work with the data within the database, you can do that so that you're not working locally on your machine to help a lot of those operations happen within the database. You can also, there's an Ultrix Server offering, which has different kinds of scalable levels in terms of processing power, but you can have all this operating on a server, or you can choose to have it on-prem, depending on your needs. I think that currently they're working on making it more robust in terms of parallel operations, to have multiple kind of functions and operations happening in parallel. And so I think that they're working to expand that more.
And I'd like to say just on the scalability side of things, I think this question really highlights why Ultrix is such an important tool, particularly when paired with a product like Tableau. Data visualization softwares can, over time, as rows are added to the data or as a set of data becomes larger, can slow down and become less responsive. And Ultrix is positioned really well in the market to eliminate a lot of kind of that problem where data visualizations will kind of get bogged down in high volumes of data. And so if Ultrix is leveraged kind of upstream of data visualization, we find that data refreshes run faster, the ultimate dashboards and products work better, which is precisely why we use it so heavily at Decisive Data in conjunction with our data visualization work.
Okay, well, thank you. And while we're on the issue of the flexibility of the Ultrix platform, I guess you should give us some indication of how many different types of databases you can blend. SQL seems to be a slam dunk, but tell me, what other types of databases?
Yeah, they have a plethora of different things that you can connect to. Obviously, SQL is a big one, Oracle, Snowflake, Apache Spark, Teradata, Amazon Redshift, Databricks, generic ODBC, Hive, Impala. Let's see. Those are the ones that I see right off the bat, and those are all the ones that you can do just within database processing. And so there's several more, I think, where you can just import the data from as well.
Terrific. Well, thank you. Thank you. Now, Tessa, if I want to write custom R code, does that mean that I need to install R script on my machine?
Install our server. Well, when you install Ultrix, there's a whole another install for R itself that goes along with the initial install of Ultrix. That's the predictive tools, and it will install R for you. In the latest version of Ultrix, they came out with an integration of Jupyter notebooks within Ultrix, which does help with the development of custom code within Ultrix. You can also write your custom code in RStudio. And one thing that I ensure to do on my machine is ensure that my R Studio and my Ultrix are actually pointing to the same R instance, so that I'm more confident that when I develop things in R Studio that it will be immediately transferable into Ultrix.
Okay, and thank you. And by the way, I guess I should ask immediately about Python. Does Ultrix accept Python script?
Yeah, it does. They have an SDK for Python integration, and then, like I said, they recently came out with an integration of Jupyter Notebooks within Ultrix itself, so that you can actually be developing Python within Ultrix.
Okay. Now, several of the audience members have asked questions around principal component analysis. Some of them have indicated they are not clear on what PCA is, and others have asked if when you use PCA and you then update the data, are the principal components that are derived from the new data the same, or are they consistent with the PCA derived from the original training data? So maybe you'd start by just saying a little bit about what PCA is and why you selected it and what information it provided forward, and then you can talk about whether or not updating PCAs remains consistent with the original model.
Sure, yeah. So in my experience, and it probably wasn't totally necessary in this particular example, but the main functionality of PCA is when you're dealing with lots and lots of different variables, and let's say you did want to go through an exercise of segmentation or something like that, and dealing with that many components is very difficult to accurately and concisely apply to another algorithm. So the intention of principal component analysis is to reduce the number of variables that you're using moving forward without reducing the amount of information. So it's basically a machine learning algorithm that takes the information from all the different variables that you've input into it, and it basically optimizes other vectors that basically incorporate all the information from those input variables. And in the particular workflows that we designed, the PCA macros, when you have new data that's coming in, it's regenerating and relearning what the optimum principal components are for that particular data, and then those are the values that it outputs based on your inputs.
Okay, well, thank you for that explanation. You know, we asked a minute ago about scheduling Alteryx workflows to make sure that the data is always up to date, that that our clients see. Does that work from the desktop or only from the server?
You can do that in both. You can do that in both. Yep, you can run schedules in either. Okay. Well, Tessa, Hunter, Scott, hey, thank you. Great answers to some good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Tessa, Hunter, and Scott and the Alteryx team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for September 13th, that's our next DSC webinar, which will be Embedded Analytics and Data Science, a Shell Oil Case Study. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central at the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Ultrix for their sponsorship, and particularly our speakers, Tessa Jones, Hunter Barrett, and Scott Troughton, for their insight into today's topic. This is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on September 13th. Have a great day.